Exercise 3. Mathematical induction, series type. Prove by mathematical induction that 1 plus x squared plus x n to the minus 1 equals 1 minus x to the n over 1 minus x for n greater than or equal to 1. Alright, now pause the video and have a go at this one. Okay, now for n equals 1, the left hand side equals just 1. The right hand side is equal to 1 minus x over 1 minus x, and that's equal to 1. Just one little point here, x cannot be equal to, notice this one, x cannot be equal to 1. I should have made that statement. Otherwise this makes it a 0. So this will be true, but x cannot be equal to 1. Therefore, the left-hand side is equal to the right-hand side. Therefore, the statement is true for n equals 1. Now, assume statement here, I'll asterisk this, is true for n equals k. That is 1 plus x squared plus x to the k minus 1 equals 1 minus x to the k over 1 minus x. Now, prove the statement is true for n equals k plus 1. That is 1 plus x squared plus x to the k minus 1 plus x to the k is equal to 1 minus x to the k plus 1 over 1 minus x. Now, as before in the previous exercises, what I need to do is I need to add that one there to both sides of this one here. Oops, I better put down that's A, isn't it? That's our P. So I'm going to add x to the k to both sides of A. Alright, so we'll do that. So I've got 1 plus x squared plus x to the k minus 1 plus x to the k equals 1 minus x to the k over 1 minus x plus x to the k. I'll just highlight that. So that's the one I've added to both sides of the statement here. Okay, both sides been added. Okay, that we've assumed that'd be true, so that's okay. Now, the algebra comes in now. Therefore, we have to prove that this 1 minus x to the k over 1 minus x plus x to the k is equal to the right hand side of P, because the left hand sides now match up. Right, left hand side, oh there goes the kookaburras. Must be getting excited about this mathematical induction. Okay, now putting over a common denominator of 1 minus x, we get 1 minus x to the k plus x to the k, 1 minus x all over 1 minus x, and of course that's equal to 1 minus x to the k plus x to the k minus x to the, add the indices, k plus 1 all over minus x. And these guys go out. You get 1 minus x to the k plus 1 over 1 minus x, which equals the right hand side of p. Okay, therefore the statement is true for n equals k plus 1. Now, the statement is true for n equals 1. So, by mathematical induction, the statement is true for all n greater than or equal to